All right, guys. Now, before we start this piece of notes, I want you to use your calculator, please, and see if you can give me the answer. Okay, punch it in. I want you to punch in log of 0. And then I want you to use your calculator and punch in log of -1. Then let's try log of 1 over 10. Then last one, I promise, log of 21. Okay, so can you tell me what happened when you punch in log of 0? What did the calculator say? Did it say error, not possible maybe, right? How about log of -1? Another error, not possible? How about when you punch in log of 1 divided by 10? Did it give you an answer? And what kind of answer? Positive or negative? Oh, did you say a negative answer? Oh, good. Negative solution. Okay, negative number, I should say. Let's just write negative number. How about when you punch in log of 21? Did it give you an answer? Was it a negative answer? Oh, positive answer. Okay. So the reason I want to test you guys is this. As you can see, log does not have an answer if there's a 0 right there. Log doesn't have an answer if there's a negative. Okay, so log could only give you an answer, students, if it's bigger than 0. Okay, now punch in log of 1 for me. What does it give you? Exactly. So for log, students, we can never ever have anything at 0 or a negative number. So that's why it's important, because we need to understand that so we can check our answers when we are about to solve, okay? So solving logarithmic and exponential equations. There are 2 options here, students. Let's read through them. Option 1, when we have all logarithms. So if you have log base b of x equals log base b of y, now this is only true if x equals y, since the bases are the same here. So step number 1, get only 1 log on each side. Sometimes you will need to condense them by using the properties of logs. Get the input equal to each other. And then solve normally, but don't forget we have to plug your x back and check. The reason we want to check is so that these numbers right here, students, are not 0 or negative. There are another options here, because not every single term will have a log sometimes. So if that's not the case, so for example, if we have log base a of a, log base b, of a, students, equals x, okay, then we can write it as an exponential. Or if we have an exponential, we write it as log. So first we want to isolate the log by using the properties of logs to condense if needed. Write in exponential form, and of course you solve it as normally, and then you check your answers. So let's try these examples right here. Determine which option to use. So hey, option 1 and option 2. Then solve. Leave the answer in exact form. Remember, pay attention, exact form. And using your calculator and round to 3 decimal places, okay? So example 22 says log base 7 of 2x minus 1 equals log base 7 of 3x minus 5. Students, the bases are exactly the same. Just like an exponent, you can drop them. Okay, so if we drop them, we have 2x plus 1 equals 3x minus 5. Now we solve normally. We will move 2x over here. At the same time, we will move the 5 by adding 5 to both sides. That's allowing us to cancel those x's on this side, cancel the 5 over here. So this is going to say x equals 6. And since x equals 6, it's a nice number, it's an integer, we don't need to use our calculator. Number 23 says log base 2 of 6 plus log base 2 of x equals 3. Students, as you can see right now, the left side has 2 logs, so we have to condense them. Now in log property, if it's an addition, it becomes a multiplication. So 6 times x equals 3. This is going to be case number 2. Case number 2. Let's go and read. Because case number 1, when we have 1 log on each side, like question number 22. Now case number 2 says, hey, once you have isolated the log by condensing, write it in exponential form. Yes, let's do it. Exponential form, your base is 2, so 2 to the third equals 6x. Well, 2 to the third, guys, is going to give us 8. 8 equals 6x. Divide both sides by 6 here. Divide by 6. So that's going to give us x equals 8 over 6, which is going to be reduced by divide by 2, so 4 over 3. So final answer is going to be x equals 4 divided by 3. Now, if you have to use a calculator to punch to give me the decimal approximation, it should say 1 point, right? And then you have a third, so 3, 3, 3. So both exact and decimal approximation. Example number 24, very similar, except for example 24 has some coefficients that need to be brought up as a power. So natural log, students, of x squared plus natural log of 2 to the third. So those powers got to go in there first. Then we have an addition of log. So that's going to become a multiplication. But we can also do this before we multiply. 2 to the third, guys, is 8. Okay, so now we can multiply x squared times 8, which I'm going to write 8x squared. Okay, so natural log of 8x squared equals 5. Well, guys, natural log is really log base e of 8x squared equals 5. This is going to allow me to rewrite it as an exponential. So this is case number 2. I'm writing C2 for case number 2. So e to the 5th equals 8x squared. Students, e to the 5th. E is an ugly, irrational number that's rounding about 2.7. So e to the 5th is, again, another ugly number. Don't get scared. We have to divide both sides by 8. Okay, we don't want to round yet until the end. So now we have e to the 5th divided by 8 equals x squared. We need to take a square root, just like this, okay? And whenever we take a square root, we would like to have a plus or minus. Okay, so x equals plus or minus big radical e to the 5th divided by 8. But here's the problem, students. We cannot, remember, we have to check, right? And this x right here can't be a negative number. So we are going to eliminate this negative number, okay? So we only need to keep this positive number of square root, big square root, e to the 5th power divided by 8. That's the same thing as saying square root of e to the 5th over square root of 8, okay? That allows us to simplify square root of 8. Yes, we can. We already studied how to simplify square root. Square root of 8 is 8 times 8 times 8. So that's going to be 2 times square root of 2. We have to rationalize this square root of 2 by multiplying top and bottom by square root of 2. That will leave us on the bottom. 2 times 2 is now 4. On the top, 2 times e to the 5th, and this is your exact, okay? So now let's check your calculator out. Take out your calculator. We're going to punch it in and get a calculator approximation, I should say, about 3 decimal places. Okay, so my calculator is spitting out 4.307. Now, if you don't get that answer, guys, do this first. Do the square root first, okay? So do the square root of 2 times e to the 5th. Leave it, all of that ugly decimal. Hit enter. Then whatever that ugly answer is, hit divide by 4. And then it should come out to be 4.307. Example 25 says log base 4, log base 5 of 4 plus log base 5 of x equals log base 5 of 36. You got 3 logs here, 2 on the left side and 1 on the right side. Remember, we can't drop the logs unless the bases are identical, and you can only have 1 on each side. So the first thing is we need to condense, okay? So we have an addition of log that will allow us to write a multiplication. So 4 times x equals log base 5 of 36. Now, because we have 1 log of an equal base, let's drop it. So now we have 4x equals 36. Go ahead and solve for it, guys, and box up your final answer. Hopefully, you got x equals 9. All right, guys, example 26 says log base 4 of x plus 2 plus log base 4 of x minus 4 equals 2. Whoa, 2 logs on the left and no log on the right. So not fair, but that's okay. So what we need to do is, since this is an addition, we need to condense. So log base 4 of x plus 2 times x minus 4 equals to 2. Since we only have 1 log on the left and no log on the right, we need to rewrite it as an exponential function, okay? So 4, guys, to a second power equals, we need to distribute this in a little bit, so x plus 2 times x minus 4. So 4 squared, students, is going to be 16. Distributing this, that's x squared. That's going to be minus 4x. In the middle now, 2 times x is going to be positive 2x. 2 times negative 4, y'all, is going to be negative 8. Then we are going to combine like terms. So 16 equals x squared minus 2x minus 8. Remember, we have a quadratic here, so we need to make sure we move this over, set it equal to 0, so we can factor it out to solve. So 0 equals x squared minus 2x minus 24. Our job here, student, is to factor. So let's see. X minus 6, okay, times x plus 4. That would give us negative 24, and then add together to give us negative 2x in the middle. Perfect. Take each factor, set it equal to 0 to solve. So this one will allow us to say x equals to 6. This one will allow us to say, this is supposed to be plus 4. When we move the 4 over, that's negative 4. But let's look really quickly. Can we keep both? Okay, remember, we have to check to make sure. The reason we check is this little guy in here cannot be 0 and cannot be negative, okay? So when we chuck in 6 in here, 6 plus 2, it's 8, positive. Awesome on that side. 6 minus 4, positive. I can keep the 6. Let's check in the negative 4. Negative 4 minus 2, oh no, that doesn't work. If one of it doesn't work, then we don't really care. We can't keep it, okay? So students, we only have one answer at x equals to 6.